how closely related two variables are, often we look at something called the correlation coefficient. Now, what that measures is two different things. So if you're asked, hey, what does the correlation coefficient tell you about two variables? It tells you both the direction and the strength of the relationship. We'll get more into that idea of direction in the next learning target, but just so you know, it actually can tell you both of these things. We also call the correlation coefficient the R value because a lowercase r is the variable used to represent it. Now, R value itself, and I will say this, when you look at different sources, these numbers will be different from different sources. For our purposes this time, we're going to say -1 and +1 are perfect correlations. And they would say that in other resources too. And perfect means, oops, actually it would help if I actually wrote the word perfect instead of perfection. Perfect means this. When I graph these two variables against each other, like height versus shoe size, if I were to graph them, the points that I graph are perfectly linear. I could draw a line and hit all of those points. This would be a perfect positive correlation, so a correlation coefficient or R value of +1. This would be a perfect negative correlation, so the R value would be -1. Notice the one with the positive slope is a positive correlation and the one with the negative slope is negative. But the strength of their relationship is the same. This is perfectly linear. This is also perfectly linear. Here's where the rest of this gets to be where there's some variation. For this year and for this class, we are right now going to say from -0.8 to -0.99 and from +0.8 to +0.9, that's where the correlation is strong. Which means the points are not perfectly linear, but they're not as scattered as they can become. The reason I say that you're going to see some variation, depending on what texts or websites you go to, they might say it's anywhere from 0.7 to 0.99. I've even seen some that say from 0.5 to 0.99 can be considered strong. For this class right now, we're going to say from 0.8 to 0.99 and from -0.8 to -0.99. And then if it's 0, I'm going to skip down. If it's 0, it's right in the middle, there is no correlation. If I look at a scatter plot of no correlation, it's going to look kind of like a shotgun blast. I mean, the points are going to be everywhere, and I couldn't even imagine how I could draw a line of fit through those points. The closer it is to 0, the weaker the correlation is. And then if it's anywhere from the -0.79 to -0.01 or +0.01 to +0.79 for this course at this time, we're going to say the correlation is weak. Again, you do get into some other things where they talk about different numbers with that, or they talk about strong, moderate, and weak. We are not going to make those differentiations this year. So I have this R value of +1, and those points are perfectly linear. I can draw a line through all of them. This one also has an R value of +1. If my points were like this, as long as there's a little bit of a rise, the R value is +1. So it's positive because it means they are perfectly linear. What it does not tell us is the slope of the line. The slope of the line is not 1. All I can tell is that the slope of the line is positive, and that's it. So I'm going to look at these, and they give me these choices for R values. And I don't always do them in order. So I'm going to look, and I'm going to see this, first of all, is perfectly linear, and the points are ascending, or as x increases, y also increases. So my R value is going to be exactly +1. Same kind of thing here, perfectly linear, but a negative slope for that line of fit that I could draw in there, so R is -1. And then I'm going to cross those off because I've already used them. Then I notice what's left. There's one that says 0. Well, The second graph, I can't even imagine. I could see kind of where a line could be drawn here. I could even see on some of these other ones where I could draw a line that would sort of describe what's happening with those points. This follows the trend of the data. It looks like it's a good average line for that data. I wouldn't even know where to begin to draw that for the second graph. So that's why the R value given these choices is 0. I don't see a trend to that data. Then I notice what's left. I have these two that are negative, but this is much more scattered than this. So this is weaker than this one. Well, weaker means it's closer to 0. They're both negative, but the one that is closer to 0 is the weaker one. So this one's negative 0.3, and this one is negative 0.8. Same thing with the other two. Positive, but much closer to linear. Positive certainly, but more scattered. And since weaker is closer to 0, this is R equals 0.3, and this one is R equals 0.8.